But people seem to really like this thing called the law of sines and how it works out. It works with triangles or not right triangles. So I'm going to call this angle. We're going to go A, B, and C. What side would this be? A, B, or C? This would be side A. What side would this be? C. How about this one? This would be B. Now, as we said before, this whole thing called SOHCAHTOA and this thing called the Pythagorean theorem. We like them, but we can't really use them so much anymore. We can't because, well, we don't have a right triangle. So what we're going to do is we're going to come up with a new formula, and we're going to prove or derive how we come up with that formula. It's going to be pretty straightforward. No, we're not taking derivatives. You are college level, but in order to take derivatives, you have to take college algebra and college trig and calc first, and then you'll be ready to take derivatives. All right. Can somebody here think of a trig function, either sine, cosine, or tangent, that deals with these three right there? Sine, cosine, or tangent? I hear tangent, I hear cosine. Opposite over hypotenuse. Very good. So the sine of angle A is equal to what? H over B. Opposite over hypotenuse. H over B. Good. You all with me? That's one of the toughest steps in this proof. Can anybody think of a trig function, sine, cosine, or tangent, that deals with those three? It's sine as well. In fact, I could write sine of B is equal to what? H over A. You're almost there. You've done a great job. See, when I'm given triangles, I'm often not given that height piece in the middle there. So I want to get rid of H. Look at these two expressions. What do they share in common? What do they both have? They both have an H. I'm going to solve for H by multiplying both sides by B. If I multiply both sides by B, I get B sine of A is equal to H. And now I'm going to multiply both sides here by what? A. And I get A sine of B is equal to H. Now this is where it starts to really come together. Folks, if they're both equal to H, then they're both equal to each other, right? If they're both equal to H, then they're equal to each other, right? So I could say that B sine of A is equal to A sine of B. I got rid of the H altogether. And finally, one last step that makes it look kind of prettier. So we could leave it like that. Some books do leave it like that, but I'm going to divide both sides by AB. If I divide both sides by AB, what happens on the left-hand side? The B's cancel, and you're left with sine of angle A over A is equal to what happens to the right-hand side? And I get sine of angle B over side B. And turns out we could include C as well. We would get sine C over side C. This is called the law of sines. The law of sines, what's that? So I'm just adding that in. We could carry out the proof to do it for C's as well. Be no problem for us. Sine of A over A is equal to sine of B over B is equal to sine of C over C. it kind of has a nice flow to it, doesn't it? Sine of an angle divided by its opposite side. And it makes our work really, really easy. For example, flip to your next problem. Did you guys have one? Is it on your front page? Okay, mine's on the other page. It says solve the following triangles, and we're going to do this. We're going to draw a triangle. We're going to label it A, B, and C. So my good friend Gavin, you guys know Gavin? Say hi, Gav. Gav just admitted to the class that he still doesn't fully understand the whole SOHCAHTOA thing. Is that correct? The nice news is that you don't have to fully understand SOHCAHTOA to do this lesson. It's actually, it's easier than SOHCAHTOA, most people say. And what I want to do is I want to find all 6 of these. Remember we used to do that? The difference is we used to say that C was always 90 degrees. Well, look at what we have here. A is 42 and B is 80. So I have 42 and I have 80. And it says side A is 10. Does anybody know how I could find angle C? Yeah, I take out my calculator and I go 180 minus 80 minus 42. And I get 58 degrees. Is everybody okay here? Notice that we don't have a 90-degree angle. When you don't have a 90-degree angle, you don't use SOHCAHTOA, you don't use the Pythagorean theorem, you use the law of sines. It requires you have an angle and its opposite side. So what angle do I have that has an opposite side? Yeah, so I set it up. Sine of the angle 42 divided by, what's its opposite side? 10 is equal to sine of, would you like to find side B or side C? You choose. You want to find B, so then do we choose 80 or 58? We choose 80, sine of 80 divided by B. How do you think we go about solving for that? We do, we cross multiply. And if you cross multiply, you get B sine of 42 is equal to 10 sine of 80. If I wanted to solve for B, what would I do to both sides now? Very good. Sine of 42. I divide over there. So I'm going to go to my calculator. I'm going to type this in real carefully. 10 sine of 80 divided by sine of 42. And I get 14.72. What I would like you guys to do on your own is see if you can find side C. You can set it up the same way. Sine of 42 over 10 equals sine of 58 over, instead of B, you would do C. You can't use the Pythagorean theorem because it's not a right triangle. I'm sorry that that's dumb. See if you can find side C. Go. All right, my check here gives me 12.67. And so that's how we solve that one right there. We are done here at 2:15. We're going to take a break there, and then we'll get into the next example tomorrow, and we will be able to work on an assignment tomorrow. There are no tricks, trust me.